Okay, so like I said, I'm going to make a recording for the rest of the review for test 1. I'm going to go ahead and leave it open through this weekend until Sunday, like original, because I don't think there's that many power outages. So I'm hoping that everybody still has power and can still take their test by Sunday. If I have to work with individual people, that's fine also. Now, the first thing that we did, or the last thing we did on Wednesday, is we did go over all of 3.7 and then the first 5 problems of the review. So what I'm going to do now is start with number 6 on the review, which is another graph problem. And it says to graph the function f of x equals -4 plus the absolute value of x. Okay, and it also, on these are the ones where it also gives you the chart that it wants you to finish filling out. Once you finish filling it out, then it wants you to do the graph in Math Lab. So all I'm going to do is take this straight to my y equals, because this is the same thing as saying y equals -4 plus the absolute value of x. So if you go to your y equals and clear it out, type in -4. So remember the negative button's underneath the 3. So -4 plus. Now remember where absolute value is. If you go to the math and then go 1 over here to number, it's the very first thing under number. You'll see that ABS. So hit absolute value and then you'll put your X in there. So here's your X button. Now, if you'll want to, you'll just arrow to the right to get out of the absolute value. So -4 plus the absolute value of x. First things first, let's see what shape this makes. Since it is an absolute value graph, it is going to make a V. Now, the second thing is we're going to hit second and then hit the graph button again to get our table, because remember, it gives us part of the table. It gives us all of the x's it wants us to fill in for. So -2, -1, 0, 1, and 2. And then it wants us to fill out the y part, or I think it actually says f of x. Okay, because remember, these two things mean the same thing. So all you're doing is you're going in this x column, looking for these x's, and putting in the y that goes with it. So what goes with the x being -2? -2. X being -1. So again, I'm just going down that column. So -1 goes with -3. Then 0 will go with -4. +1 will go with -3. And +2 will go with -2. So I'm just filling out the rest of this chart. So -1 went with -3, 0 went with -4, 1 went with -3, 2 went with -2. So that fills out the rest of the chart. And then it's going to want you to use the graphing tool to graph it. Now remember, when we are graphing the absolute value graphs, it makes us plot the vertex first, because remember, this is going to make a V. This point right there is going to be the vertex where it makes that point of the V. So when you're looking here, it's where it stops going in one direction and then it starts mirroring itself. So this point right here, that's your vertex. Okay, that's when it stops. Look, see how it's going from -3 down to -4. Then it starts going back up. That means it has stopped going down and it's starting to go back up. So that point right there is your vertex, which is going to be the first point you're going to graph. So the first point you're going to graph is going to be that 0, -4. So left and right 0, down 4. And then it'll ask you to plot a couple more points. And then you can just pick any of them out of your chart. So -2 would be left 2, down 2. Let's see. So we did one on this side of this one. Let's do one on this side. 1, -3. So to the right 1, down 3. Again, once you have created those points, it'll make that V graph for you. Okay? And I'm going to pause for a second. I got to get something to erase with. Okay, moving on to number 7. This is another one where we're going to graph. It's going to give us a chart to fill out. We're going to fill out the missing numbers of the chart and then graph. So we have f of x equals -x² minus 5. And it gives us our chart. And the same numbers, -2, -1, 0, 1, and 2. So again, I'm just going to take this to my y equals, clear out the last one, type in -x² minus 5, so negative. Then hit your x. Then hit your squared button, right? This button, even though it says x² on it, it really just puts a squared on top of your x like you want. And then minus 5. All right, let's look at it. It's going to be a U shape this time, right? It's upside down, but it's still a U. That's because it's an x² graph. So to fill out the rest of my chart, I need to hit the second button and then go to the table. And let's see, I am using these right here. This one, -2, -1, 0, 1, and 2 are the numbers that are in the chart that I'm filling out, right? That's the chart that you're filling out, is -2 to +2. So I'm just gonna choose the numbers that are in the Y that go with these. So let's see, -2 goes with -9. -1 goes with -6. 0 goes with -5. 1 goes with -6. And 2 goes with -9. So then you will go to the graph to plot any of these points that it's asking for. Since it's a parabola, you can use any points. You just have to first tell the math lab that you want to graph a U-shaped parabola and then plot any of the points. So -2, -9 would be left 2, down 9. -1, -6 would be left 1, down 1, 2, 3, 4, 5, 6. 0, -5. So I didn't go left or right at all, and then just went down 5. Then +1, -6, so to the right 1 and down 6. And again, once you don't even have to do that many points in Math Lab. Once you've done a few of those points, it is going to connect them for you. Okay, now number 8 gives us a picture of a graph, and it says, is this the graph of a function or not? Yes or no? Now remember, what is the test that you use to decide this? It's the vertical line test, which means if you draw a vertical line, which is the one that goes straight up and down, and you can touch it more than once, which I do here and here, that means it is not a function. You can only touch it one time for it to still be a function. If you can touch it more than once, then it is not a function. Okay, number 9. Okay, I'm going to pause it for a second and draw the graph up here to work. Okay, so here is the problem for number 9. So we've got a graph here. And it wants us to find 4 things on this graph. The first thing it wants us to find is f of 2. So again, if you have your sheet out with you, it's probably going to be easier. And remember, when you're doing this in Math Lab, there will be a little magnifying glass for you on problems like this, where you'll be able to zoom this a lot bigger so you can see exact points, okay? Because the first thing it wants me to find here is F. All right, sorry about that. I'm not sure what happened. I think I lost connection or something, but this is the problem for number 9. The first thing it's going to want us to find is F of 2, which means go to your graph, find where the X is 2, right? Because the number inside the parentheses is always your X. So if I go over here to where X is 2, and then I go up and touch the graph, which would be right here, it wants to know what is the Y that goes with that. That's what F of 2 means, is what is happening when the X is 2. Whatever that is, that's going to be your Y. So when I trace it over to the Y-axis, it shows me that the Y is also 2. The second part of this wants to know what is the domain. Okay, the domain is what are all the X values that are represented by this graph, which means how far left and how far right does this graph go? So when I'm looking at it, starting from this point, it goes forever to the left and up this way, and forever to the right and up that way. So if you say forever left and forever right in that statement, which I do, left and up this way, right and up that way, that's going to mean that your domain is all real numbers. Since it's a V, it goes left and right forever. That's what those arrows mean. Okay, the next part says, what are the X values when F of X, or in other words, when Y equals 1? So when you come over here to the graph and you find where the Y value is 1, which is here, trace it over to the green V and see what goes with that. So when I trace that over, you'll notice that it touches it here and here. So it wants to know what are the X values when Y is 1. So here the X value would be 3. And here is another spot that it touches it. And here is where the X value would be 5. So when Y was 1, and you traced it over to touch the green V in 2 spots, it lined up with 5 and 3. Okay? Now it wants to know what the range is. Now the range is your Y values, which means however far up and down the graph goes. Okay, so you'll notice that it's starting from the point of this V, it goes up this way and up this way. It doesn't ever go below here. Since it doesn't go below here, this point right here is the lowest Y value that you are going to see on this graph. So we need to know what is the Y value at this point. Well, the Y value, since it's not up at all, right? It's still on the X-axis. It hasn't gone up or down. The Y value is 0, which means your range, if you're looking right here, your range is going to be, the Y is going to be greater than or equal to this 0. So your range is the Y value has to be greater than or equal to 0. Okay? Number 10 gives us a function and then asks us to find the domain of that function. Now, this function does have a fraction. If you'll notice, the function is g of x equals 6 over 2 minus 9x And it wants us to find the domain. Now remember, when you have an x in the denominator of a fraction, that's going to give you a restriction on the domain because the denominator of your fraction cannot be 0, right? You can't have 6 divided by 0 because that is undefined, which means whatever your denominator is, say that cannot equal 0. So set it up equal to not equal 0, and then just solve it like a regular equation for x. So you get rid of this positive 2 with a negative 2 to cancel it. So then you have negative 9x cannot equal negative 2, and then divide by negative 9. So let's see, x cannot equal, here we have a negative over a negative, which would turn it into positive since it's negative divided by negative. So x cannot equal positive 2/9. Okay, moving on to number 11. This is going to give us 2 separate functions. This is the section where it would give us 2 separate functions and then ask us to do something with the 2 functions, like add them together or sometimes subtract. This one's going to actually ask us to put one over the other. So the first function is f of x equals negative 11x plus 13. And g of x equals x squared plus 2. And it wants us to find f of 10 over g of 10. So we're going to find these 2 things separately. We'll find f of 10, and then we'll find g of 10, and then we'll put the f of 10 answer over the g of 10 answer, and then reduce it if we need to. So let's see, the first thing we have is f of 10, which means you go to your f function and replace its x with a 10. So when I do that, I'll have negative 11 times 10 plus 13. Then I'll do this math. So negative 11 times 10 gives me negative 110 plus 13. If you need to type that in, type that in. Here is not where you want to make your mistake. So if you have negative 110 plus 13, that's going to give you negative 97. Actually, I'm going to write that over here. Give myself room. So negative 97 is that part. So now I've done the f of 10. Now I need to do the g of 10 part. So I'll go to my g function and replace its x with a 10. So I'll have 10 squared plus 2. So 10 squared gives me 100 plus 2 gives me 102. So let's see what I have. I've got negative 97 over 102. So let's make sure, because it's going to say to write it in simplified form. So remember to check that. So negative 97 divided by 102 and hit enter. Remember, it's going to give you a crazy fraction, but then just math, enter that. And it still says negative 97 over 102, which just means that was in its simplest form. Okay. All right, number 12. Again, it's going to give us 2 functions, one for f of x and one for g of x. So f of x is negative 5x plus 4. G of x is x squared minus 2. And this wants me to find g minus f of x. So what we're going to do, since we're finding g minus f, you need your g function first. So it's just g of x. So all I'm doing is I'm just coming up here for my g function and writing whatever g of x is. Well, it tells me what g of x is. It's x squared minus 2 Then you're going to do minus the f of x. So when I come up here, remember, when you're subtracting f of x, you're going to subtract this whole entire function. So it's got to be in parentheses. So let's see, minus negative 5x plus 4. So now we'll need to distribute this negative. So I'll just bring down the x squared minus 2. When I distribute this negative, it turns this into a positive 5x and that a negative 4. And then the last part of this is just to combine your like terms, always starting with your highest exponent. So you have x squared here. Then you're looking for your x's. The only terms you're going to be able to put together is that term with that term. So we're going to put those at the end since those are our constants. So I still have the plus 5x, and then the negative 2 and negative 4 together gives me negative 6. All right, number 13. Looks like it gives us two more functions, f of x equals x squared minus 20, and g of x equals 19 minus x, and I'm finding f minus g of negative 10. So this time, you're going to be finding two things. You're going to find f of negative 10 and g of negative 10 and get your two answers and then subtract them. So let's find the f of negative 10 first, which just means to go to your f function and replace its x with negative 10. So I have negative 10 squared minus 20. Negative 10 squared gives me positive 100. Bring down the minus 20 to get 80. So there's my f of negative 10. Now I need to find my g of negative 10. So I'll go to my g function and replace its x with negative 10. Be careful with your signs here. I've got 19 minus, replace this x with negative 10. So do you see how you're going to have a minus negative there, which actually means 19 plus 10, which gives me 29. So I found f of negative 10 was 80. G of negative 10 was 29, and it wants me to subtract these two. So I need to do 80 minus 29. What does that give you? Gives you 51. All right, number 14. Gives me two functions. Again, 1 over x minus 8 is my f of x function. G of x is 9x to the third. So what it wants me to do, this is the one where it wants me to find the domain of three separate situations: the domain of the sum, the domain of the difference, and the domain of the product of these two functions. So what you're doing here is you're looking at either both of these two original functions and seeing if there was a restriction in either one of those. So the restrictions that we are aware of right now are with x's in the denominator. So I see that here. So when I find the restriction on this domain, that's going to actually be the restriction on the domain of the sum, the difference, and the product. They are all going to be the same answer. We just know that this denominator cannot equal 0. So you set it up to not equal 0. Solve it for this x. So add the 8. So x cannot equal positive 8. So that is going to be your domain for every single one of these. X is a real number, and that is where you are going to have to type this in. You're actually going to have to type in the x, the cannot equal symbol, which will be down there at the bottom when you're typing in your answer. 8. You have to type in this whole thing for all 3 answers. All right, number 15. All right, it gives me 2 functions again. F of x equals 3x minus 7. And g of x equals 7x minus 42. And it wants me to find the domain of f over g. So rewrite your f function over your g function. So 3x minus 7 over 7x minus 42, which when we put one over the other, we do notice that we are going to have a restriction, right? Because we've got an x in our denominator. So just like on that last one, the denominator, 7x minus 42 cannot equal 0. Solve it for x. So get rid of the minus 42 by adding 42. So 7x cannot equal 42 and divide by 7. So x cannot equal 6. So again, when you type in your answer, x is a real number. And don't forget, you're going to have to type in that whole thing. The x cannot equal 6. All right, number 16. So now we're going to be given 2 functions, and this is when we got into the composition of the functions, the f of g's and the g of f's. So on number 16, we've got f of x equals 4x plus 3. And g of x equals x to the 3rd, and it wants me to find f of g of negative 4. So remember, when we were finding the composition of functions, this is what we always looked for first, whatever was on the inside. So the first thing you're going to do is find g of negative 4. Which means you're going to go to the g function, which is this one right here, and replace its x with negative 4. So when I do that, I have negative 4 to the 3rd power, which gives me negative 64. Okay? After I do the g part, then you bring down whatever this part is. So you're going to find f of whatever the last answer was. So in this case, it was negative 64, which means now you're going to go to your f function and replace this x with negative 64. So let's see, I have 4 times negative 64 plus 3, and then do that math. So let's see, 4 times negative 64 gives me negative 256. Bring down my plus 3. So when you add that, you get negative 253. All right, number 17. All right, here are my 2 functions are f of x equals 9 over 1 minus 5x, and g of x equals 1 over x. So there's several different things we're doing on this problem. We're going to first find f of g of x, Then we're also going to have to find g of f of x and then the domain of each of those. So since I am limited on board space this time, I'm going to do this first. I'm going to find f of g of x, and then I'm going to find its domain while it's still on the board. And then I'll have to erase it and do the second part, the g of f of x and its domain. So let's find f of g of x first. So let's see, when we're finding f of g of x, remember we always find what's on the inside first, which is g of x. So when I go find that, what is g of x? Well, it tells me in the problem that g of x is 1 over x. So that part is done. Now you find the outside, which is the f part. So what are you finding f of? You're finding f of your last answer. So f of 1 over x, which means you're going to go to your f function, and wherever you see an x, you're going to replace it with a 1 over x. Okay, so let's see. I'm going to replace this x with 1 over x. So I've got 9 over 1 minus 5 times, replacing this x with 1 over x. So let's multiply the 5 times the 1 over x. So let's see, I just brought the rest over, 9, and I brought over the 1 minus. When I multiply straight across here, you can kind of think of it as 5 over 1. So when I multiply straight across, I'm going to get 5 over x. Now, remember, it's not going to let you enter your answer like this because you've got too much fraction going on. You've got a fraction that's in a fraction. So remember how you fix that is whatever the denominator of this fraction that's inside the fraction is, that's what you're going to multiply the top and the bottom by. So because you're going to try to cancel that denominator. So since the denominator of that is an x, that's what I'm going to multiply by on top and bottom. So let's see what that gives me. On top, 9 times x gives me 9x. So that's a carry multiplying the top. Now this x comes to both of these down here. So let's see, x times 1 gives me x minus, here's why you did it. When you multiply x times 5 over x, x's actually cancel each other out. So you're just going to be left with minus 5. And that is your answer to f of g of x, 9x over x minus 5. Okay, now when you're finding the domain of this, you actually have to look in 2 different spots for restrictions. You look in your final answer for restrictions there. So I can see one restriction here because I have an x in the denominator. So I know x cannot equal 5. X minus 5 cannot equal 0, right? Because your denominator can't equal 0. Let's see, where else do I need to look for restrictions? When you found g of x and got your answer, you have to look for a restriction there, which there's another restriction, right? This denominator, which is just x, also can't equal 0. So I need to see what my 2 restrictions are. Luckily for us, this one's restrictions are already solved for. X can't equal 0. All I have to do to solve this one is add the 5 to both sides. So now I know that x also can't equal 5. So here are my 2 restrictions, 0 and 5. So your domain can be anything but 0 and 5. So what they want you to do, and luckily it is a multiple choice problem, but they want you to show this in interval notation, which means from everything from negative infinity to positive infinity, except 0 and 5. So the way that you would show that would be you start at negative infinity, then the first number you would come up to exclude would be the 0. So that tells that everything below 0 is good. Then it's going to have this little U, which means in union with or and. Now, after this, I want to include all the numbers between 0 and 5, right? The only two numbers that are completely excluded are 0 and 5. The numbers below 0 are good. The numbers between 0 and 5 are good. And the last interval would show all the numbers above 5, which would be from 5 to infinity. So this is what the domain would be. So there's half of that problem. We found f of g of x. Now we're going to find it the other way around, g of f of x. So again, the first thing you find is the inside, which would be f of x. So when I go find f of x, it actually tells me what f of x is in the problem, right? It's 9 over 1 minus 5x. So there's the first part. Then you find the second part, the g part this time. And what are you finding g of? Whatever your last answer was, which is 9 over 1 minus 5x. Which means go to your g function, and wherever you see this x, you're going to replace it with 9 over 1 minus 5x. So when I write the g, I'll have 1 over, instead of x, write what you're going to replace it with, which is what is in this parentheses. So 9 over 1 minus 5x. Now remember, I can't enter my answer like this because, again, you've got too much fraction going on. And remember how we took care of this on the first part of this problem. Whatever the denominator is of the fraction that is in the middle of the fraction, that's what you're going to multiply the top and the bottom by so that I can cancel this denominator. So since it's 1 minus 5x, that's what I multiply the top and the bottom by. So let's see what that does. Here I've got 1 times 1 minus 5x, which just gives me 1 minus 5x, right? If you multiply something times 1, nothing changes. But look what it does to the denominator. This is why we did it. That 1 minus 5x canceled that one. So we're just left with the 9. So there's your answer to g of f of x, 1 minus 5x over 9. Now it wants us to find the domain. So remember where the two places you're looking for restrictions, the very final answer, which is a fraction, but look at the denominator. There's not an x in it. Since there's not an x in the denominator, there is no restrictions here. The other place that you're looking for your restriction is the first part of the answer. So this one does have a restriction because it does have an x in its denominator. So I just need to know that 1 minus 5x cannot equal 0. Solve it for this x, so subtract the 1. I got rid of the 1, so now I have negative 5x cannot equal negative 1, and then divide by negative 5. So here, x cannot equal, since it's negative over negative, it just can't equal 1/5. So there's only one restriction on this domain. So when we write this in interval notation, we just need to show everything from negative infinity to positive infinity except for 1/5. So from all the numbers below 1/5, which would be negative infinity to 1/5, and then 1/5 to infinity to show all the numbers above 1/5. Okay, now that one was number 17. Number 18, here, it wants us to use the horizontal line test to determine if this function is, or if this is one-to-one. So remember what the horizontal line test says, if there's anywhere you can draw a horizontal line, oh, my pen's not working very good, but a horizontal line, if you touch it more than once, okay, even down there, if you touch it more than once, which I touched it one time here and one time here, so I touched it twice. More than once means no, it's not a one-to-one function. A horizontal line test that just touches it one time would be, yes, a one-to-one function. Okay? All right, number 19. All right, determine whether the function is one-to-one and then find its inverse if it is. So f of x equals 3 over x plus 4. Oops. So this one, if I'm going to, first of all, it is one-to-one. These are all going to be one-to-one. So if it's one-to-one, it wants us to find its inverse. Now remember, to find its inverse, the first thing you need to do is rewrite your f of x as a y. Right? Because f of x and y mean the same thing. So y equals 3 over x plus 4. Okay? Oh, hang on just a second. Okay, so after you change the f of x to a y, then you're going to invert the x and the y. So now you're going to have x equals 3 over y plus 4, and then you're going to solve it for this new y. Now, unfortunately, the new y is in the denominator of a fraction. So the first thing you're going to do is multiply both sides by that denominator, which is that y plus 4, because that'll cancel that. Okay, and what it does is on the other side, when I distribute this x, I'll have x times y, which gives me xy, plus 4 times x, which is 4x, equals, over here I just have a 3. So now here's the y that I'm trying to solve for. So when you multiply both sides to get that y out of the denominator, it puts it up here, but you still have to get it by itself. But now I know how to do that. I just need to subtract the 4x from both sides. So that gets rid of the 4x. So now I just have xy equals negative 4x plus 3. Now, to get this y by itself, you need to remove that x. So you're going to divide everybody by x. So when I do that, those x's cancel. There's my y equal. Here, these x's cancel. So I'm just left with that negative 4 plus, I still have 3 over x on that side. Whoops. Okay, so that was number 19. Number 20. Number 20 is when we got into the systems of equations. Now remember, we did all of this work in our calculator. So we have 4x plus 3y equals 40. And then we have 3x plus 4y equals 44. Now, remember what we did. We used the matrix function in our calculator for these problems. We created a matrix A that contains the number part of this side of the equal sign. So up top, we'll have 4, 3, and then 3, 4. And then we created a matrix B that had this side of my equal symbols. So 40 over 44. Now, when we go to our calculator, again, you don't even have to have a special program for this. It is built in all the TI calculators. So I will go to my matrix, which is second, and then hit this button right here that says matrix. Now, the first thing you're going to do is make your matrices. So you need to make sure that you scroll over to the right to edit. And then you're going to edit your first matrix A. So hit enter. Now, the first thing you have to do is tell your matrix, look, it has this information in here from the last matrix problems that we worked. So the first thing you need to do is tell this one, look, that what size you want it to be, which means how many rows and how many columns. So this matrix has 2 rows by 2 columns. So I need to tell that this right here, I need to tell it 2 by 2. So 2, enter, 2, enter. To change your matrix to be 2 rows and 2 columns. Then enter your rows here. So let's see, the top row will be 4, 3. The bottom row will be 3, 4. So just make sure that your matrix A here matches your matrix A there. Then you're going to go to second matrix. You're still editing, right? So make sure you scroll over to edit. Now this time you're editing this B matrix. So go down to B and hit enter. Now remember, it has this from our last problem that we did. We need to change it to this matrix, which is 2 rows by 1 column. So the mistakes that we were making in class were usually having to put in the right thing here. You got to make sure this says 2 by 1. So 2, enter, 1, enter. Okay, so you'll see it took off that bottom row that was there. Now make sure you put your numbers in here. So 40 and 44. So now what you're going to do is you're going to do matrix A to the -1 matrix B. So what you want to do right now is go to your straight home screen. So second, quit. Now you're going to want to type in matrix A. So second matrix. Now remember the A that you just put in there, you want to use it. So do not go over to edit. You want to use this matrix. So just hit enter. Now your -1, there's an X to the -1 button on your calculator. That's the one you push. So when I hit that, that gives me my -1. Now I need second matrix. Again, not going over to edit. I want to go down to B. So just hit down to B and enter. And then hit enter again. And there's your answer. Now remember, when you put in your answer is an ordered pair. So you will need to enter it in parentheses like that. So 4, 8 would be your answer. Okay? Number 21 is the same kind of problem, but this one's a 3 by 3. So let's see, we've got 6x minus y plus z equals -8. 2x plus 2y minus 3z equals -31. And x minus 3y plus 2z equals 22. So this time I have 3 equations with 3 unknown variables. So I'm going to make the same thing. Matrix A from this side, matrix B from this side, and then use these numbers. So I've got 6, -1 in front of that y, +1 in front of that z, 2, 2, -3, and 1, -3, 2. And then my matrix B over here will be -8, -31, and +22. So now you are going back to your matrix. So second matrix. Now, are you making new matrices? Anytime you're making new matrices, which I am, I'm going over to edit. So I'm going to edit matrix A. I need to change the 2 by 2 now to a 3 by 3. So look, it added this last row right here so that I can enter all my numbers. So enter your first row. So 6, negative 1, 1, 2, 2, negative 3, 1, negative 3, 2. So I always double check at this point that the numbers that I have entered match the numbers in this matrix. So 6, negative 1, 1, 2, 2, negative 3, and 1, negative 3, 2. Okay? Now, got to edit my matrix B. So second matrix. Now I'm making a new B, right? So go over to edit and go down. Don't forget to go down to B and hit enter. Now we need to tell it to change from, it was 2 by 1. Now I need to change it to 1, 2, 3, right? 3 by 1. So 3, enter, 1, enter. And then enter your numbers. Negative 8, negative 31, and 22. Now you want to go to your home screen. So second, quit. Now is when you want to do the matrix A to the negative 1 matrix B. So second matrix, you're not changing matrices. You want to use this matrix that you just put in there. So hit enter, hit your negative 1 button, and then second matrix, make sure you go down to B. So down to B, enter, and then hit enter again. Now, these problems, I'm going to tell you, are not going to come up with crazy answers in here. So if you get numbers that are long decimals and things like that, there is something entered wrong somewhere, okay? All of these numbers are going to come up good. And remember, when you enter it, you have to enter it in parentheses. So parentheses, that's my X, Y, and Z. So negative 3, negative 5, positive 5. Okay? All right, 22. All right, this is the egg, cupcake, and pizza problem. Okay, so remember it says by eating 1 egg, 1 cupcake, and 1 slice of pizza. So let's write these things down. Egg, cupcake, pizza will be our X, our Y, and our Z. So the first thing it says, by eating 1 of each of these, so 1 X, 1 Y, and 1 Z, a child consumes 302 milligrams of cholesterol. The second sentence says, if the child eats 3 cupcakes and 4 slices of pizza, so 3 cupcakes would be 3Y, 4 slices of pizza would be 4Z. They would consume 92 milligrams of cholesterol. And the third sentence says by eating 2 eggs, so eggs are X, so 2X, and 1 cupcake, so 1Y, the child consumes 568 milligrams of cholesterol. How much cholesterol is in each item? So what you have done is you've created a systems of equations that has 3 unknown variables. So we're doing the same thing we did in the last 2 problems. We're going to create our 2 matrices and then do matrix A to the negative 1 matrix B. So let's see what's going across the top of this first matrix. These are all 1s. So 1, 1, 1. Now, on this second row, anytime there's a missing term, that means the X is 0, then 3, then 4. The third row will be 2, 1, and then 0 for the Z. And then this this matrix B will be 302, 92, and 568. So let's go make our new matrices in our calculator. So just clear it out. Go to matrix. So second matrix. I am making new matrices again. So make sure you have to go over to edit and stay on matrix A. Here's where you're going to enter your new numbers. Here's the numbers you're going to enter for this matrix. So 1, 1, 1. Oops. 1, 1, 1, 0, 3, 4, and 2, 1, 0. So again, make sure it's 3 by 3. And that your 3 rows all have the same columns or the same numbers as here. So 1, 1, 1, 0, 3, 4, 2, 1, 0 before you move on. Now make matrix B. So second matrix, you're making a new one. So go over to edit and make sure you go down to B and hit enter. You still want it to be 3 by 1, right? You still got 3 rows here. So just hit 3 by 1 and just replace these with your new numbers, which are 302, 92, and 568. Now that I've made my 2 matrices, I want to go to my home screen. So second, quit. So now you want to do the matrix A. So second matrix, use your new A that you just made to the -1. And then your matrix B. So second matrix, you want to use this new one. So make sure just go down to B and hit enter. And hit enter again. So there's your answers, 274, 20, and 8. So my X, which is the eggs, is 274. My Y, which is the cupcakes, was 20. And my Z, which was the pizza, was 8. All right, the last 3 problems are the last things we covered in 3.7, the systems of, the inequalities, where we had the less than or greater than. This is where we did the shading. Right, number 22 says 4x minus 5y is less than or equal to -15. And it wants us to graph this. Now remember, I do want to get 2 points from here so that I can plot those points to connect them, draw the line, and then shade it. So let's see if we're going to, if I got to first get this y by itself. So I'm going to have to subtract 4x from both sides. So now I have -5y is less than or equal to, if I want to bring these 2 down, I'll have -4x minus 15. Now I'm going to have to divide by -5, right, to get this y by itself. Now remember what happens when you divide both sides of an inequality by a negative number. This symbol is now going to turn around. So these -5's cancel. There's my y. Instead of pointing to the left, now it points to the right because it turns around since I divided by this negative. So here, a negative over a negative turns to +4/5 x. -15 over -5 is +3. So this is what I'm putting in my y equals to graph, or to get 2 points to draw this line. So go to your y equals. 4 divided by 5. And then hit your x. Then +3. All right, let's just go ahead and look at it. Now, second table to get your points. Just choose 2 points that don't have decimals. So I would choose this. Let's see, I would choose 0, 3. And then all the way down to 5, 7. So I would choose 0, 3. And 5, 7. So when you plot those points, so 0, 3 means left and right 0, up 3. 5, 7 means to the right 1, 2, 3, 4, 5, then up 7. Now, remember, MathLab is automatically going to connect these 2 points with a solid line, right? Which is actually what we want in this situation, because if it has the equal to bar, that means to use a solid line. If it didn't, if it just said greater than without the equal to, then you would use the dashed line. Okay, but again, since it has the equal to bar, we do want it solid. Then after we choose that we want it solid, then we have to decide which side we're going to shade it. So this says y, where are the y values greater than this line? And greater than always means above the line. Okay? Number 24. X is less than 1. So this one's already solved for us, okay? But it doesn't have a y, so I can't take this to my y equals to get points. It doesn't have a y that I can solve for. So this is one of those special lines. Remember, the x equals a number is always going to be a vertical line, which means straight up and down. So what you're going to have to do is find any two points to where the x coordinate is a 1. Whatever this number is, that's what you're going to want your x coordinate to be. Okay? So we're going to find 2 points, which just means that you have gone to the right one. So for instance, there's 1 and there's 1, or there's 1. Any of them where you've gone to the right one. Now remember, once you plot 2 points, MathLab is going to connect those with a solid line, and you're going to have to go over into the palette and tell it you want to change it to dashed, right? This one's dashed because it doesn't have the equal to bar. And now since it's x's, we want to know where are the x's less than this line. So less than, if here's where x is 1, where are the x's less than that? All to the left of it. So you would shade to the left of it. All right, last one. Okay, this is where we had this multiple choice one where it graphed 2 separate inequalities on the same graph. And then wants to know where their shading overlaps. So the first one is y is greater than or equal to x plus 4. And the other one is y is less than or equal to 3 minus x. So we want to know where would the shading of these overlap. So I'm going to do this top line in green. The y is greater than or equal to x plus 4 in green. So go to your y equals and clear it out. And type in x plus 4. Here's your x plus 4. All right, let's just see what that line looks like. Now I'm going to need 2 points, right? So second graph. Just pick any 2 points you want out of this table. So I'll do those for top two, -1, 3 and 0, 4. So -1, 3 would be to the left 1, up 3. 0, 4 would be left and right 0, up 4. So let's see, since it does have the equal to bar, that means I'm going to connect it with a solid line. And let's see where this is shaded. It wants you to shade where the y values are greater than this line, which would mean above that line. Now, the second line, y is less than or equal to 3 minus x. So now, go back to your y equals. Change this to 3 minus x. So 3 minus, this is your x button. All right, let's graph that and see what it looks like. So it's going to be going the other way. Let's get 2 points. So second table, and then again, just pick any 2 points you want. I'll just pick these top two. -1, 4 and 0, 3. And I'll do this in blue. So -1, 4 would be to the left 1, up 4. 0, 3 would be left and right 0, up 3. And again, it's a solid line, right? Because it's got the equal to bar. This one wants to know where are the y values less than or equal to this blue line. So less than would be underneath. So the answer is, where do the blue and green shading overlap, which is in this quadrant area right here. So on the left side. So you'll notice that all of the graphs are the same except where they're shaded. The only one that is shaded on the left is that B.